Right, so this is another question on Bayes' theorem, and let me begin by saying that this question has multiple versions, which means that the values that I will be using in this video might be different from the ones that you see in your assignment, and that's okay. Uh, it's the logic. The logic of the solution is the same, right? So the only thing that will change is the numerical answer that you get, because the values you've been given are slightly different. So so don't worry so much about seeing different values. You only need to plug in the values that you get in your question, and you'll be good. You'll get the answer to your specific question, right? So that said, um, this question is about blood groups. So human blood is classified into four broad categories. So there's a blood group A, and then there's a blood group B, a third group called AB, and O, right? So all human blood is classified into these four categories, right? And O is kind of a special group in the sense that people who have blood group O are called universal donors. They can give their blood to anyone. So a very useful group, um, thank God for them. So what we are told is that 4% of the people who have blood group O are left-handed. So these are people who have blood group O, right? And 7% of the people who do not have blood group O are left-handed. Again, so these are people who do not have blood group O, and but 7% of them are left-handed. And we are also told, a last fact that's told to us is that 10% of the people in the world have blood group O, right? So these are the three facts that we have been given. So if this were the set of all the people in the world, then they could be divided into people who have blood group O and people who do not have blood group O. So O prime is the event that do not have blood group O. And there's also the set of people who are left-handed. So this is a set of people who are left-handed. So some of them have blood group O, and some of them don't. So 4% of the people who have blood group O are left-handed. So that's this set over here, right? So the 4% is calculated over the set of people who have blood group O. It's not calculated over the entire population. It's just 4% of those who have blood group O. So this first fact, so if I were to ask you, uh, given the fact that a person has blood group O, what's the probability that he is left-handed? So if I were to ask you what this probability is, let me just rewrite that, then what would your answer be? Well, that's simple. 4% are left-handed, those who have blood group O, so the answer would be 4 by 100, right? Which just boils down to 1 by 25. And if I were to ask you the same question, that given that a person does not have blood group O, what's the probability that he is left-handed? Well, the answer to that is also very simple. We've been told that it's 7 by 100. So the information we have been given, I've just rewritten it as probability expressions. And the last bit, which was that 10% of the population has blood group O, well, that's very simple. So if I were to randomly pick a person, then what's the probability that he has blood group O? Well, that's simple. That's 10%, which is 10 by 100, which boils down to 1 by 10, right? So we have all the information in as probability expression. So all the things we were told, we've just written them down as probability expressions over here. But what we are being asked is that if we randomly pick a person and that person turns out to be left-handed, then what's the probability that he's got blood group O? So the question we are supposed to answer is this: what's the probability of a person having blood group O given that he's left-handed? So this is what we are supposed to find out. Well, that's kind of easy. It's a simple application of Bayes' theorem. This is a conditional probability. So we know that probability of O given L is equal to the probability of L given O into probability of O divided by the probability of L given O into probability of O plus probability of L given O prime into probability of O prime, right? So this is the total probability, and this is just probability of L and O, right? So this is a simple expansion of the Bayes theorem. Now, in this expression over here, right? This whole big block over here. Um, we know almost everything except possibly probability of O prime. This we don't know. Now this is kind of easy to find out. So either a person has blood group O or does not. And if a person does not have blood group O, then he's in this category. So this is kind of easy to write. So this would simply be 1 minus probability of O, right? So either you have blood group O or you don't. And this turns out to be 1 minus probability of O, which was 10%, 1 by 10. And so this turns out to be 9 by 10, right? So we got this last missing piece over here. So now it's a simple case of substituting these, all the values that we know into this expression over here. So let's do that now. So probability of O given L is simply probability of L given O, that was 4%, which we had written down as 1 by 25, into probability of O, which was 1 by 10, divided by 1 by 25 into 1 by 10 plus probability of a person being left-handed given that he does not have blood group O. So 7%, that was 7%, so 7 by 100 into this 9 by 10 that we just calculated, right? So if you do the calculation, this calculation, you can use a calculator, do this on your own using pen and paper. However, this turns out to be equal to 4 by 67, right? So the answer to our question, that what's the probability that a person has blood group O given that he is left-handed, is 4 by 67. So that was the question, and that's how it's done.